BKM6 is about how to allocate capital between risk-free and risky portfolio. We will go over the building blocks for capital allocation, such as investors' risk preference, and use utility function to quantify risk-return trade-offs and identify optimal allocation percentage to risky portfolio. First, let's go over the key building blocks for capital allocation, utility, and risk aversion. Investors tend to be risk averse, meaning they want additional return or compensation to bet on a gamble compared to taking a sure thing. Economists use utility score to quantify investors' satisfaction or benefit on investment option given their risk aversion and the investment's expected return and risk. Utility function calculates utility based on three parameters: expected return of the investment, the risk level measured by standard deviation, and investors' risk aversion denoted by A. Utility scores help investors decide between investments. Investors would pick an investment that offers the highest utility possible. A commonly used utility function is expected return minus 0.5 times risk aversion A times sigma squared. It's straightforward to see higher expected return would lead to higher utility. More risk-averse investors have higher risk aversion that would make the second term of the utility function larger, so utility would be lower. For a risk-free asset, the utility equals its expected return. Because sigma is 0 for risk-free asset, the second term in the utility function is 0. The utility score of risky portfolios is also known as the certainty equivalent rate of return. It's the rate of return that risk-free investment must offer to provide the same utility as the risky portfolio being analyzed. Now let's go over the different types of investors' risk aversion. Investors have different risk appetite or tolerance. When they face the same investment option, they have different utility. Risk-averse investors require risk premium for investing in risky portfolio. They demand high risk premiums for greater risk. For higher risk aversion A, their utility is smaller. It's easy to see this relationship in the utility function. When A is greater, the second term is higher. The utility is lower. On the other hand, risk-neutral investors ignore risk and make investment decisions based only on expected return. Their risk aversion A is 0. The level of risk is irrelevant in their decision-making for investment. The utility is simply the expected return of the investment. Risk-loving investors prefer higher level of risk. The larger the risk, the higher the utility. This implies their risk aversion A is less than 0. Negative A would make the second term in the utility function negative. Double negative is positive, increasing the utility score. Let's take a look at a numerical example. We have 3 different investors with 3 different risk aversion: 2, 3.5, and 5. In the table, we are given 3 different portfolios from low risk to high risk. For each portfolio, we are also given risk premium, expected return, and the standard deviation. Risk premiums are the excess returns above the risk-free rate. Another name for risk premium is excess return. When working on a question, we have to be aware of whether the given is expected return or expected excess return. It's a common mistake to mix them up. Risk-free rate is not explicitly given in this case, but it's easy to see it's 5%. For a lower risk portfolio, expected return 7% minus 5% is equal to 2%. For medium risk, 9% minus 5% is 4%. And for high risk, 13% minus 5% is 8%. We want to find out which portfolio each investor prefers. We need to calculate the utility score. In the second table, utility scores are calculated for each investor and for each portfolio. For investor X, the high-risk portfolio offers the highest utility score, and for investor Y and Z, the medium-risk portfolio. Let's go over the utility calculation for investor X with the high-risk portfolio. Using the standard utility function, expected return 13% of the portfolio minus 0.5 times risk aversion times 0.2 squared equal to 9%. Sigma squared is just the variance. If the variance is given, we don't need to square it, so be aware of what's given in the question. Risk-averse investors face trade-off between risk and return. In the graph, we can see portfolio C has higher expected return than A and higher standard deviation than A. In this case, we need to calculate the utility for A and C to see which portfolio an investor with a given risk aversion would prefer. On the other hand, portfolio A has higher expected return but lower standard deviation than B. In this case, we can say A dominates B. This is known as the mean variance criteria. Make sure at least one inequality is strict. If A dominates B and the expected return of A is equal to B, then the standard deviation of A must be less than B. In our case, when risk-averse investors are choosing between A and B, they will pick A, even without calculating the utility score. Now, let's go over the indifference curve. It's the graphical representation of utility function. The portfolios on an indifference curve have the same utility. For example, an investor has risk aversion equal to 2. The risky portfolio expected return is 13% and standard deviation is 20%. The certainty equivalent rate of return is the expected return 13% minus 0.5 times 2 times variance of the risky portfolio 0.2 squared equal to 0.09. The certainty equivalent rate of return is the y-intercept on the indifference curve. At the y-intercept, standard deviation is 0. It's a risk-free asset. Utility equals the expected return. By the definition of certainty equivalent rate of return, we are dealing with the expected return of risk-free asset that will offer the same utility as the risky portfolio being analyzed. If we want to find out the expected return of another risky portfolio on the same curve, we just need to plug the utility 0.09, the standard deviation of that portfolio, into the utility function. For a portfolio with a standard deviation equal to 30%, we plug the number 0.09, 2, and 0.3 squared into the equation and get expected return. All three portfolios are on the same curve. They have the same utility, 0.09. To recap, the y-intercept is the certainty equivalent rate of return and also the utility for risky portfolios on the curve. If an investor has aversion greater than 2, the slope of his indifference curve is steeper. The y-intercept is lower and the utility is lower. As the standard deviation increases An investor with a given aversion would require higher expected return to achieve that level of utility. We can see it from the second graph. For an investor with a given aversion, the expected return difference between the two indifference curves is the same for all portfolios at a given standard deviation. From the third graph, we can see for the same level of utility, 0.05, more risk-averse investors have indifference curve with steeper slope because they require higher expected return. If you like our video lesson, you could find the entire Section A video lessons organized by chapter on our main website, www.actuaryfellow.com. And the best thing is, it's free of charge. Plus, you could take our quiz to test your understanding of the key concepts for each video lesson. We also offer practice exams on our supplemental study website, www.actuaryfellows.com. Our practice exams are on CBT setting, the exact same way the actual exam is being administered. Sign up and access the free package, including past exams and all past integrative questions. Happy studying! Do it once and for all.